Let's take a look at triangles, which is 10.1. We're going to look at a few different characteristics of the different triangles before we start solving them. First is an acute triangle, which is a triangle with, I'm just going to speak it out, not write them, but it's a triangle with all angles less than 90 degrees. So it might look something like this. All of our angles, this angle, and this angle, are all less than 90 degrees. A right triangle is a triangle where there's one angle that is equal, exactly equal to 90 degrees. So that's a sketchy drawing there, but we would mark that by putting this right angle symbol, which if you have a straight edge, we use like a little box like that. That's really what that's showing. So it's a right angle. So one of our angles is equal to 90 degrees, and the other two are obviously less. Obtuse triangle is a triangle where one angle, only one, is greater than 90 degrees. So if we have a triangle that looks like this, oops, sorry for the squiggles, this angle is less than 90, this is less than 90, but that one there is really big. It's greater than 90 degrees. Okay, so one angle is greater than 90. And then we have equiangular, which means all of the angles of a triangle are equal, exactly the same. And if you know how many degrees are in a triangle, which is 180, and we'll get to that in a second, you know that there's three angles, so each of them must be equal to 60 degrees. So an equiangular triangle is a triangle where all angles are equal to 60 degrees. Okay, now these ones that we've just spoken of all have to deal with classifying triangles based on their angle measures. Let's look at these next problems. They're going to give us information regarding the sides. So an equilateral triangle is a triangle where all the sides are equal. Whoopsies, sorry again. All the sides are the same. We use these little tick marks to show that. It ends up based on geometry principles that if it's equilateral, it's also equiangular. It will also have three equal angles. But that's what an equilateral triangle is. It's talking about the sides. An isosceles triangle looks like an ice cream cone. We have two sides that are equal. We show that with tick marks. And again, because of geometry principles, we end up having two angles that are equal also. These two angles are exactly the same. But that's an isosceles triangle. Two sides are the same, classifying it by its sides. And the last is a scalene triangle where we have all sides that are different. So this is different than this, is different than this. This could be 3 inches, this could be 4, this could be 5 inches. So they're all different. We're talking about sides. So when we're classifying triangles and they give us our sides, we have to determine what kind of triangle it is based on these three. If they're giving us angles and they ask us to classify it, we're going to give one of these definitions above based on the angles: equiangular, obtuse, right, or acute. Okay, and that's a small, subtle thing, but it's important to recognize because let's say, for example, you have a scalene triangle. All your sides are different. You could have a scalene right triangle, a scalene obtuse triangle, a scalene acute triangle. You could have a whole bunch of different varieties, but if they're asking you what to classify it and they've only given you the side lengths, and you need to classify it as scalene because that involves side lengths. Okay, now let's move on. Perimeters. Perimeter, we use P. It's when you add up all the sides. So add up all sides. And we could put a formula with that. If we were to take a triangle and we label this as A, B, C, we could say A plus B plus C. So basically you just add up all the sides. Area is a little bit different. Area is equal to 1/2 the base times the height. Or some people write it as base times height divided by 2. So really what that's saying is if we have a triangle, it doesn't matter what it looks like. Actually, let me not draw that one. Let me draw a different one. We'll draw one that looks like this. Okay, this is my base. My height, they're going to give you the height. It's going to go straight up and down. The way you know it is because they mark it with a right angle. This is the height, and it even kind of looks like it makes an H. So we have our height, our base, and then you would just either multiply that by 1/2 or divide it by 2, same thing. And where that comes from is that if you have a rectangle, we know that the area of a rectangle is length times width, or base times height. Well, since a triangle is just half of that, that's how we get 1/2 base times height. Special features, as we said above, there's 180 degrees in every triangle. All right, let's try some problems. Example 1, the perimeter of a scalene triangle, so sides, they're giving us sides here, is 65 centimeters. The length of the first side is twice the length of the second side. The length of the third side is 20 centimeters. Find the lengths of the other two sides. So in this picture we have drawn just a triangle, a scalene triangle. All the sides are different. Now we have to go ahead and solve to find out the lengths of the other sides. For the first side, they tell us the length of the first side is twice the length of the second side. So 2 times second side, because it's twice the length. The second side, they don't give us any information on that one, so we don't know anything. And the third side, they tell us is 20 centimeters. So it doesn't matter which I label first, second, third. I'm going to call this the third side and 20 centimeters. Now, I don't know side 2, so I can call that X, since I don't know the second side. So I'm going to label this X. And then the first side is 2 times whatever the second side is. Well, since we're calling the second side X, the first side is going to be 2 times X, or 2X. So now we have our 3 sides, and they're telling us that these sides, the perimeter, totals to be 65. So I'm going to do X plus 2X plus 20 is equal to 65. Combine like terms, subtract 20 on both sides. I get 3X equal to 45. Divide by 3, X is equal to 15. Now I can go ahead and substitute that back in. X is 15 centimeters, and this is 2X. That must be 2 times 15, or 30 centimeters. So find the lengths of the other two sides, 15, 30, and that one was given 20. Okay, let's try another one. If you take a look here, perimeter of an equilateral triangle is 42 meters. Find the lengths of each side. So it's an equilateral, so all the sides are the same. We don't know any of the sides, so we can call each of them X, 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 X. And we're told that the perimeter is 42. So X plus X plus X is going to equal 42. 3X equals 42. Divide by 3. X equals 14 meters. So they're all 14 meters. Okay? Let's try the next one. And you can go ahead and label these if you'd like.